Now students, continuing with the elements, compounds and mixture, we will be doing that how to distinguish between a compound and element. How to distinguish? It's a very important question because elements also comes under pure substance, compounds also comes under pure substances, isn't it? So that is, I've said you in the last AV that compound is a pure substance formed by the union of two or more elements and which is being formed by a fixed composition by weight. The elements, they combine together, they come closer to each other, they form a union and they form a molecule or a compound, but the composition is always constant, it is fixed, whether by weight or by volume, whatever you can say that. So on that basis, how can you differentiate between element and compound? See, listen carefully. Whenever a compound is being heated, alright, it always undergoes decomposition. Compound, it always undergoes decomposition. That means there is a loss in weight. Listen carefully, there is a loss in weight always. But whenever an element is heated, there is a gain in weight. Because elements, it's not going to decompose further. For example, mercury. On heating, it gains oxygen to form mercuric oxide. Gains oxygen, mind it. Copper, on heating, gains oxygen to form copper oxide. Any particular element, oxygen reacts with hydrogen to form water. Alright, hydrogen reacts with chlorine to form HCl. Always there is a gain. Alright, always there is a gain. For that purpose, you can find the elements undergoes addition reactions. Always. Addition, synthesis, direct combination reaction, which we call it as. But compounds, always there is a loss in weight. Whenever a compound is heated, there is a loss in weight. We can say that. For example, let us say you have done this experiment in the lab. Might be you will take mercuric oxide. Let us say you have taken 100 gram of mercuric oxide and you will be heating it. Mercuric oxide is red color. We can say that reddish color or reddish brown. Reddish color is the correct. We can say that it's reddish brown color. Mercuric oxide, you will be taking it. On heating, you will be getting, what is that? Mercury plus oxygen. Let me balance it, 2Hg plus O2. So let us say the weight of what you can say mercury you got, it's 92 gram. Let us say, it's an example I'm giving you. So what you find is that from 100 gram to 92 gram, because why? There is a loss in weight. Why? Oxygen is being released into the atmosphere. How do you know that you got mercury? You will be getting shining globules on the surface of the test tube, on the cooler part, on the upper part of the test tube. You will be getting shining globules, which is nothing but mercury. We can say that. Clear? So in this way, from red color, it gives you shining globules of mercury, that is 92 grams. So from 100 gram, it goes to 92 gram. That's the most important thing. There is a loss in weight. So whenever you heat a compound, there is a loss in weight. But whenever you heat an element, there is a gain in weight. Alright, that's a very important thing to distinguish between element and a compound. If you are not able to distinguish this, alright, it's very, very important. So hence, what is the characteristics of compound we came to know from this? That compounds always have got a fixed composition, they have got a fixed weight, in which they combine, the elements combine with one another and they form a compound. Alright. Now, compound is represented by definite formula. You can see here, mercuric oxide, we have got a formula. We don't have a formula for milk, we don't have a formula for air, we don't have, because they are the mixtures. Alright, milk is a mixture, air is a mixture, we don't have a formula for mud or the clay, we can say that, because they are the mixtures, we can say that. So we don't have a fixed formula for it, mind it. Now, when a compound is formed, always there is a loss of energy or gain in energy. That energy is either evolved or energy is either absorbed. Always, mind it. Alright. Now, whenever a compound is formed, the compounds basically they are homogeneous in nature. And the most important thing is that they do not retain the properties of the elements. Whenever a compound is formed, always a new set of properties we are getting it. For example, when you prepare water. Now, hydrogen, you know, is a gas which is itself, it does not support burning, hydrogen. It goes off with a pop sound. But oxygen is a gas which supports combustion. It helps in burning. But water, when it forms, it neither, burns itself, means burns off with a pop sound, nor it helps in burning. Rather, it extinguishes fire. That's it. It has got different properties from that of its elements. Let us take the example of sodium chloride. Common salt, which you are taking it every day. Sodium is a metal Got it? It's a that is not shining. It's a dull colored metal. We can say that it's highly reactive. As soon as it comes in contact with water, it causes explosion. It catches fire. Got it? Sodium. It possesses these properties. We can say that. Chlorine, it's a highly poisonous gas. It's a greenish yellow colored gas. It's a highly poisonous gas. Got it? Chlorine. We know that. But when sodium chloride it forms, when sodium combines with chlorine to form sodium chloride, it completely loses its properties. We know that sodium chloride you are using in day-to-day life. In our food, we are using sodium chloride. Salt, common salt, we can say that we are using in a day-to-day life. It has got completely and entirely a different set of properties. Sodium chloride has got completely different set of properties from what? From sodium and that from chlorine. So whenever a compound is formed, it has got its own properties. It has got its definite set of properties, different from that of its combining elements. Always remember this particular one. Now, the properties of the compound, you cannot separate it by physical means. You have to separate it by chemical method. You have to separate it. Physical means you cannot separate. I have told you earlier also, you cannot separate the constituents of what you can say water or constituents of sodium chloride. Alright, you cannot separate it by boiling, by what you can say by filtration, by boiling or by sublimation. In this way, you cannot do it. You have to go for a chemical change. Either you have to go for electrolytic dissociation, like when you pass electric current through acid related water, last class I said it dissociates into hydrogen and oxygen. Which one? Water dissociates into. So that is a chemical process. Similarly, sodium chloride, if you take molten sodium chloride or aqueous solution of sodium chloride, then you will find sodium and chlorine, sodium chloride dissociates into sodium ions and chloride ions. So you cannot separate the constituents of a compound by physical means. You have to separate it by chemical methods. You have to separate it. So these are the characteristics of a compound, we can say that. These are the characteristics of a compound. Fine. So you understood what is a compound, what is an element. Now let's come to a mixture. Now mixture is a material obtained as a result of mixing of two or more substances. It can be elements or compounds. Alright, in any proportion, in any ratio, you can mix it. Alright, any ratio you can mix an element or a compound and you can get a mixture so that the components do not lose their individual properties. Whenever a mixture is being formed, the components do not lose. Listen carefully, the components of a mixture, when a mixture is formed, the components of a mixture do not lose its individual properties. It do not lose. It retains its individual properties. How? Very simple. You take a glass of water and you add that is little bit of sugar to it, let us say. Sugar is what? Sweet. So sugar solution which you will be getting in. It's a mixture, it's a homogeneous mixture. What it will be? It will be sweet only. For example, you take a glass of water, you add some salt into it. Salt is what? Salty in nature. Now when you add salt to a glass of water and stir it, it forms a homogeneous mixture. So what is that? What is the taste of that particular solution? Salty only. So what you find is that it retains its properties. Whenever a mixture is formed, that is the elements of the compounds, they combine with one another in any proportion, any ratio it combines and it forms a mixture. Alright, and the mixture always retains the properties of the elements or the compound by which it is being formed. Got it? Always that is, you need to understand it. So, if you see the characteristics of a mixture, what is that? It has got a variable composition. Yes, composition you can vary. How? For example, you have taken a glass of water containing some salt. You have added some salt. You can add more salt to it or you can add more water to it also. If you add more water to it, it becomes dilute. Means the salty solution, what you can say is that the taste, it fades away slowly. We can say that. It's not so salty, it's less salty in nature. But if we add some more salt to that particular glass of water, it becomes more salty in nature. So you can vary its composition. You can vary it in this way. Next, the properties, I said you already, it retains the properties of the combining elements of the compounds. We can say that. It retains the properties. No chemical change takes place. That means neither any heat is evolved nor any absorbed. Whenever, when you add sugar to water, when you add salt to water, any heat is absorbed or evolved? Nothing. Got it? No, it is not an endothermic or exothermic reaction. No change in heat is evolved or absorbed. We can say that. And you can separate the constituents by physical method. Yes. You take what you can say sugar solution and you heat it. On heating, water will evaporate, leaving behind sugar. You take salt solution, heat it. On heating, salt will remain behind. Suppose you have taken chalk dust and water. That's also a solution. It's not a homogeneous mixture, it forms a heterogeneous mixture. Mixture, now I will tell you, it's two types, homogeneous and heterogeneous. It forms a heterogeneous mixture. How can you separate what you can say chalk dust from water? Filter it. On filtration, you will get chalk dust on the filter paper. Remaining what you can say water behind, water you will be getting as a filtrate, and chalk dust you will get a residue on the filter paper. In this way you can separate it by physical method. Got it? And no energy is involved. Got it? For example, you take iron and sulfur. Now iron, you know, that is what you can say, just to mix it. Iron, sulfur, you take iron and sulfur and you mix it. What it forms? A mixture. Alright, it forms a mixture. How do you know it forms a mixture? You take a magnet near to the particular mixture. You will see iron particles will cling towards the magnet. Will cling towards the magnet. Alright, it's being attracted towards the magnet because iron retains the properties. On forming a mixture, it retains the properties and no energy change is taking place. No chemical change is taking place. But when the same iron and sulfur, if you heat it, it forms iron sulfide, FeS. Now you bring a magnet near to the FeS and try to attract the iron towards it. Will it do? No, not at all. Not at all, you can see that. So it does not retain the properties. When a compound is being formed, it's a compound now, FeS, iron sulfide. A compound is formed. It does not retain the properties of the iron. It does not retain. So that's the difference between a compound and a mixture. We can say that. Here, if you take iron and sulfur and you mix it, just simply mix it mechanically. Mix it and bring a magnet near to it. You will see the magnet will pull the iron fillings towards itself. But here on heating, when it forms iron sulfide and you bring it a magnet near to it, you will see that iron does not cling towards the magnet. Similarly, if you take a mixture of iron and sulfur, got it, and you put this mixture in a carbon disulfide solution, you will see sulfur will dissolve in it. Sulfur will dissolve in carbon disulfide solution. Got it? Take a mixture of iron and sulfur and put it into carbon disulfide. Sulfur will dissolve in it. But if you put this FeS in carbon disulfide is CS2. It's a solvent for dissolving sulfur. We can say that. You will see it does not. It does not dissolve in it. Got it? So it does not retain the properties of the elements, the combining elements. In this way, you can differentiate between the compound and a mixture. By taking an example, you can differentiate. Now, just now I was saying you that mixtures is of two types: homogeneous and heterogeneous mixtures. Homogeneous mixture means a mixture which have got a uniform composition throughout its mass or throughout the entire what you can say substance. It's known as a homogeneous mixture. But heterogeneous mixture means a mixture whose composition differs from point to point. It's a heterogeneous mixture. Example of heterogeneous mixture, we can give it, there is nothing but clay we can give, or the air, the air around us. Definitely the air which is available in your house and the air which is available in the steel plant and the air which is available near the river bed, and the air which is available in the hills, on the hill slopes, are the same? No, it is not the same, because in different places it contains different constituents. In the air which is in the steel plant, it contains more amount of pollutants. The air in the hill slopes, it is free of pollutants, we can say that. So definitely it's a heterogeneous mixture. That's an example of heterogeneous mixture. Then we can say nothing but that is your clay. It's an example of heterogeneous mixture. Clay. It consists of sand, because see, clay means the soil which is available. And the soil which is available in your house and the soil which is available in the river bed and the soil which is available in the seabed are the same? No, not at all. Isn't it? So it differs from place to place. You can see that. You have read this in geography. This about the soil. So soil forms a heterogeneous mixture. We can say that. It forms a heterogeneous mixture. In this way, what you can find is that it forms a heterogeneous mixture. Got it? Like petrol and water. Petrol does not dissolve in water. It's a heterogeneous mixture, we can say that. It's an immiscible liquid. It forms a heterogeneous mixture. Alright, you take some sand, sugar and sawdust and you mix it. It forms a heterogeneous mixture. Got it? But what is an homogeneous mixture? Homogeneous mixture is an alloy. Alloy, you know, that is brass, bronze, steel, the steel plates. They are the homogeneous mixture. Alright, that forms a homogeneous, because there the components are mixed but in a definite ratio. We can say that. It's not a compound, it's a mixture. Understood? Because it does not retain the properties of the combining elements of the compounds. Then the iodized salt. The iodized salt consists of what? Sodium chloride and sodium iodide. It's a mixture. Iodized salt, not salt. Iodized. The salt which you are using in your house nowadays. It's an iodized salt. It contains iodine. So it's a mixture of sodium chloride and sodium iodide in a particular ratio. That is a homogeneous mixture. We can say that. Milk is a homogeneous mixture. Then the gold which you're using, 22 karat gold, it is a homogeneous mixture. Tap water, it's a homogeneous mixture. It consists of mixture of calcium chloride, magnesium chloride. Sometimes the tap water is also heterogeneous in nature because it differs from place to place. We can say that. Clear? From different places, the tap water it differs. Clear? It depends in the season. In this season, rainy season, we can say that. Clear? In this way, you can find the examples of homogeneous and heterogeneous mixture. We can say that. Basically, homogeneous mixture has got the same properties throughout. A salt solution, sugar solution, got it? Iodized salt, they are all homogeneous mixture. We can say that. Heterogeneous mixture, I said you, the air, the different places, the clay or the soil which is available, they are the heterogeneous mixture. We can say that. Clear? So these are the differences of elements, compounds, mixtures. We came to know about it. Thank you.